detail, although these particular handouts are pretty good. The machine did a very good job. The presentation and all the other details will be on the website if you're interested. If you're not interested, that's okay too. Let me start. I just want to add a couple of things to that sheet that's going around. There's a couple of references that I didn't put on there, frankly, because I ran out of room. When Dave showed you the QRP quarterly for the summer edition, there is another article in there by VE2TH, Mike Boisenalt. Mike is in Quebec City, and I've worked Mike many, many times on the air, and he's done an awful lot of work with buddy poles. And he has now taken the buddy pole and scrapped a good chunk of it and has developed a new mount for it, and he now mounts it on a cyclone fence in his yard. He also now sports a little KX3. He'd been using an FT817 and an ICOM 703 for a while at QRP levels. And it's a very interesting article. It's a terrific reference point to see what somebody else has done with a commercial antenna and has made it smaller and made it a little more effective. And I can tell you it works because I work in regularly. The other one I want to talk about is April of 2011. There was an article by Brian Wingard, N7RVD. And I just happened to bump into him after his article was published in QST. And I talked with him on the air, another QRP guy who travels all over the country backpacking. And he has a vertical antenna somewhat similar to the first one that I made. And coincidentally, I had just finished mine. He had already built one. When I looked at his, I did a double take, and I said, wow. I tried a couple of things that he did. I didn't like the way they worked, and I modified mine a little bit. You'll learn a little bit more about that today. So those are two additional references. The other references that are on there all talk about vertical antennas for the field. That's their prime impetus. Some give some more detailed construction information. Others just show you pictures. Other guys just simply say, this is where I went, this is how long it took me to climb up the hill. I planted it, worked a couple stations, and that's fine. But those are good because they're a little exciting to read about. Okay, I can figure out how to use this thing here. There we go. Oftentimes the last thing you put together for your field operation or even think about is the antenna. Each one of us has a radio of some kind. We have all the accessories, the keys, and all that sort of stuff, and the cables we've made up, and all that sort of thing. And we have back here somewhere, we say, you know, we need an antenna. We have to get the RF out somehow. Somehow, there has been an awful lot talked about. You throw a piece of wire into the tree, you drape a little wire on the ground, you plug it in, and by golly, you can work the world. Under certain circumstances, yeah, you can. But for most of us, that's not the way we go. There are all kinds of antennas you can use in the field. Random layers, end-fed, dipoles, and verticals. And basically, all the antennas together that we look at are all dipoles in one configuration. They all have a driven element, they all have a ground element, they're positioned in 14,000 different directions, and they're still dipoles when you're all done. Stretch them all out horizontally, there they are. So, what I've done here is I've done a little bit of a study on verticals. They're not good all the time, they're good a lot of the time, but they're not perfect. I don't think any antenna in the field is perfect, but if you're not backpacking, this is a great antenna. If you're backpacking, you better have a strong back because you've got to carry this thing and all the rest of the stuff with you. However, the type of field work that I do, which is basically I drive up in my pickup truck, I find a real nice spot, about 30 feet away, I plant the antenna on the ground, deploy the radials, 5 minutes later I run the coax up to the truck, I'm on the air. That's all there is to it. And I operate 99% in the field QRP. At home, probably 80% of my operation is all QRP CW. And I will tell you that with this antenna and others like it, and another vertical that I've rebuilt at home, I literally work the world with it, and I can do so under normal conditions, not the stuff we've had the last month. So, verticals right up here, they work really well. They're easy to put together, they're easy to set up, they go up in just minutes. Both of these antennas you can set up in 5 minutes or less without really straining yourself. I will tell you that about 3.5 weeks ago, my wife was getting ready to go down to Milwaukee for a week, and the dog and I were sitting around in the family room and looking outside, and I said, you know, it'd be a great day to get on the air a little bit here. I'll operate out in the backyard, it's nice and sunny. I put the vertical up, got my little K1 out, put a little battery onto it, and I worked a station out in Washington. It was running an MFJ Cub at 1 watt, and we had about a 10-minute QSO. I worked a station in Los Angeles for a little bit, and I had a 25-minute QSO with a station in Deming, New Mexico. All using the very first antenna, which we'll get a chance to look at shortly. So, for me, that's a rush. I built it, I designed it, I experimented with it, and it works magically. So, when you're on the field, you're going to find, I don't find trees. I don't know whether they escape my vision or what, but I never seem to be in the right spot to find trees. I don't even have trees at home I can put things in. So as a result, I decided I would build something that would be standalone, ready to operate when and where I wanted to. It has to be really lightweight. Even though I am not backpacking, I don't want to have to, you know, be Charles Atlas out there trying to set up an antenna. If you're using a full-sized commercial vertical antenna, they get a little bit long, they get a little bit awkward to work with at times. Whether you're using the Mosley verticals, or using the high gains, or Cushcraft, or you're using the butternuts, whatever they are, they all have to be tweaked a little bit for the installation where you're setting it. This one really doesn't. Number one item on my list had to be cheap. And I built mine using whatever materials that I had, except I paid $4.69 for a 2-foot long piece of 2-inch PVC at Home Depot. And that's only because I used up the rest of my inventory at home on something else. That's the only thing I had to buy. Everything else you can scrounge around, make, modify, whatever you want. And you'll see 2 different approaches to that. You can make these things from all kinds of stuff. I've been fortunate enough, I found an old Cushcraft A4S that was in just horrible condition. It had been propped up for a number of years on about a 15-foot mast. The coax was green. The 2 of the traps were broken. One element was snapped and bent down. And I said, I'll take it. And the guy couldn't work fast enough to help me get it out of his yard. Let me tell you, there is a tremendous amount of aluminum in those things. And it's all telescopic, and you can make things fit beautifully. A wire wheel, or some fine sandpaper, or some 4/0 steel wool, and a little bit of elbow grease, you can make that thing look like brand new. And each one of these antennas are made from that antenna. You can also make them out of all sorts of other stuff. Damaged or inoperable motors, armatures, field windings, all that sort of stuff just contain tons of copper wire. And the 2 of these are made out of some field wire out of an old motor that burned out. Finally, you gotta be able to make sure that these things can be repaired in the field. You know, you really hate to find what you think is the perfect spot on the perfect day, and conditions are just the way you want them to be, and you get out there and you find out something doesn't work right. You want to be able to fix it, or you dropped it, or a wire broke, or something like that. These can be fixed on the spot. They're basically nothing more than a long piece of wire. If you got a clip lead, you can clip lead the problem You can twist some wires together, you can scrape them with a penknife and then twist them up, and believe me, your transmitter won't know the difference. Neither will anything else. There's nothing unique about these antennas, and I want to tell you that right now. Anybody can make these things. You can make them out of wire, you can make them out of tubing, you can actually take a piece of dowel rod, stretch a piece of wire, tape it on both ends, and you've got the equivalent of a nice round tube of aluminum. It works the same way. It tunes the same way, except it's about 1/100th the price. And if you've got the wire, it's even cheaper. I've done it both ways. And these happen to be made out of tubing, and again, only because I had it. I've collaborated a lot with people in the field that are using antennas. I simply like to steal their ideas. I don't have a lot of original thoughts myself, but I'm really good at copying things. And when I got a chance to see some of these things close up, and I learned some of the things that people experience that do backpack and do go out in the field a lot. It's amazing what simple things you learn and you pick up about them, especially with working with the coil. A lot of experimentation. The first time I put it together, it worked. The second time I tweaked it, it worked better. The third, fourth, fifth, and sixth times I fiddled with it, it worked even better. And each time they came up with something a little bit later that said, you know, what if I tried this? What if I tried that? And when I got all finished looking at this thing, I thought, why didn't I do it that way in the first place? It's pretty common sense. So, just bear with me. This presentation is not about necessarily how to build one in detail, although you're going to see how I build it. It's basically what I did. So, let's take a look here. This antenna right here is the second one that I made. It's the second vertical. And in comparison, this one is a Bushcraft, or excuse me, is a 4BTV Hustler. This antenna right here, I picked up last year, and it was completely broken. It had been stored for something like 10 or 12 years. One of the traps was completely shot. One of the elements was missing. The spider for 40 meters was gone. And it was really in terrible shape. And I completely rebuilt that from scratch. It took me somewhere about a month and a half of rather consistent work. I decided to rebuild everything on it because I wanted to be able to have something that I could compare the field antennas to. This one right here is ground mounted, and it's got a dozen 30-foot buried radials under it. It's got a nice ground system. It's neatly done. It's got all new radial plate for it, so I can put things together nice and neat and clean and keep them that way. And believe me, it works. At times this thing will outperform my center fed Zep. It sits about 30 feet in the air. When I want to work DX, that's my antenna of choice. And in QRP, it gets me through on the first, second, or even the third call. I can usually work the station if the stations have a reasonably good signal. This antenna here, whoops, wrong one. This one here is 10 feet shorter than this one is. It has a single coil in the middle, not a trap. It's got a small base, which we'll see in much more detail shortly. And it just simply plugs in the ground. There are 3 surface radials that are deployed, each about 16 feet long, which is an 1/8 wave on 40 meters. And that's all I use. That and a piece of coax, and I'm done. There are 3 taps on the coil. I have those marked, and I had set those using an antenna analyzer. And I periodically go back and check them to make sure that everything is still stable. And I clip it on there, plug it in the radio, and away I go. It's that simple. These antennas, this particular one here uses telescoping elements. The other one uses a telescoping antenna of sorts. It's got a real small footprint, as you'll see. And by the way, these things will easily handle 100 watts. They'll handle considerably more than 100 watts the way they're built. So you're not limited practically by power with common equipment these days. The first version we're going to talk about is this one right here. This is about 12 feet tall. It covers 40, 30, and 20 meters. There's a 40-inch section, which is the base section right here. This is the coil. And then there's another one up here. And this one, by the way, I'll tell you from here all the way up here is a 100% former 20-meter hamstick. And I say former. It's, if you've ever taken a hamstick apart, it's basically, you've got a brass base, or brass alloy base, and it's got a wire that's brazed to it. That's the start of the wire that goes up, and then you see that it slowly wraps itself around until it gets to the center. And there's this neatly wound coil in the middle. Depending upon the band, it's only about 3/8 of an inch in diameter. Let me tell you, it's small. And then it zips up to the top, where it's again raised on to another brass alloy. And then there's what they call a stinger, or if you will, it's just simply a stainless steel rod that expands in and out, and you can set the frequency by that. SWR. What I did is I took the whole thing down, and by the way, the wrapping that's on there is nothing more than shrink tubing. Take a razor blade and just cut it off. Take the wire, leave yourself about that much on the top and the bottom, so you got something to solder to. I mean, why go through and re-braze all this? Cut the wire out, take the coil out in the middle, and you've got a nice half-inch diameter rod of fiberglass. And you've also got the adjustable antenna, or the adjustable element on top. So what I did is I simply took a single piece of wire from the bottom to the top joint, soldered it, I taped it with electrical tape. Voila, there's my top element. You can usually find a hamstick for, I've seen them go for as little as $5. Somebody just wants to get rid of one. They haven't used it, they haven't been able to get it to work right. These antennas work, but they don't work very well. There isn't much to them. The key element here is you need a good ground plane to go with that hamstick. And there just isn't enough room. Everything is compressed down. So this is the first antenna here. The second one is about 13 feet long, and this is a little more robust. It's a little prettier, but it does basically the same thing. The coil is wound differently, and that's because I wanted to include 80 meters in there, or get as close to 80 meters as I can. The reason? Chuck here decided that he likes 80 meters occasionally. And so I thought, because he and I are planning on going out in the field anyway, if he ever gets the two-band board for his K1, we'll be able to operate on 80 meters as well. The idea is he and I are going to set up two different antennas, two different sites, not far apart, one on one band, one on the other, and have a good time. So that's the reason these antennas are different, but they're both very similar in construction. Let's start at the bottom. Okay, this is what the bottom looks like. It's pretty simple. It's nothing more than a piece of aluminum tubing. At the very base, I took my jigsaw and I simply cut it so it's got a little bit of an ellipse here, which is nice for putting it in the ground. Put it in the ground, put a little piece of 2x4 on top and whack it in. That way you don't ding up the top of the tube. It goes in real easily. If you don't happen to have some nice unfrozen ground around, it sticks very well in a snowbank. This particular one is coax fed. I did that only because I had the stainless steel bracket available and I had some extra clip leads. This is the clip lead that clips to the driven element. The rest of it is all grounded. There are 3 wires, which are the radials, and I happen to have them different colors only because no matter how carefully I am that I roll these up, everything tangles up when I decide to employ it anyway. So this way it's real easy to figure out which radio goes where. And that's all there is to the base. In order to insulate the base up here, I have an insulator that fits in here and also fits in the driven element. Keeps about an inch apart, and there's your insulator. What did I use? Well, I'll tell you. In this particular antenna, I've got a piece of 3/4 inch dowel. Works just great. I put a little bit of varnish on it and sanded it down, put it in the hole, and it works great. And if that breaks, you can find a twig or a stick or something to put in there. It's only going to go down so far. There's a couple of screws down here that won't let the thing go down any further. What I have here are some wire staples. And we typically buy these when, or something like them, when we start digging out radials and putting them in the ground. This is a great thing to be able to put over the wire, tap it down with a hammer, cover it all up, and it stays put. You don't have to worry about it migrating back up to the surface while the ground covers it up. Well, these are really nice because they're sharp, and at the very end of each one of the radials there is I formed a loop and soldered it. This goes through the loop and it sticks in the ground. So when you put the radial down, there it is. Theoretically, you should try to space these things 120 degrees apart. I've yet to be out there with my protractor doing that. I'll tell you, just get them down. One thing I caution you not to do, and you'll find in one of the reference articles, the fellow had this thing on his little camera tripod. He didn't use this, he used a camera tripod, and he had the radials, and he forgot to put the radials out. They were just all in this big ball of wire at the bottom. He couldn't work anybody until he got those radials stretched out. Then he was working people like that. So if you want to take a closer look at what that thing looks like. The other one is somewhat similar to it, with the exception you're going to find that there's a banana plug on here. Well, I happen to have a couple of banana plugs that were rather robust. So on the piece of coax, one piece, the ground strap plugs in here, the driven element plugs in up here, and that's how I connected to the original one. And it works fine. They're just two different approaches. The rest of it's the same. Okay. Right up here is where the three radials attach, and you'll see it when you see these as they go around. You'll see where they're screwed in. I used self-drilling, self-tapping sheet metal screws that they use for putting rain gutters on your house. Then I use a Velcro strap. I don't know if you've seen those little Velcro straps or not, but you can get them at Home Depot. They are, they look like this. They are really nice. They are designed, and were originally designed to be used on plants. I've never used one on a plant in my life. I'm now through my 6th roll of these things.
Yeah, they come in a nice roll.
They do. They come in gray and they come in black, and you buy a black one and a gray one at the same time in a blister pack. And I don't know, what are they, about $5?
They weren't much.
They're just great. They stay outside well, they tie up real well, they're great for putting cords together, and they hold nice and tight. I mean, really nice and tight. So what I did is I put a collar of those on there, so when you stretch the radials out, you're not putting tension on the point where you've actually soldered the wires onto the solder lug that you've screwed into the base. It's a strain relief. It's a real simple and easy, cheap one. Okay. Here's the other part of the base that I was just describing. This is the one that uses the coaxial feed on it. Okay, let's take a look at the first coil. I can't separate the coil from the base on this one. It was never designed to be separated. But let me talk a little bit about what this thing is. This has just happened to be 40 inches long, and it just happened to be this length when I looked at it and I found it in the garage. And I said, well, I guess that's where I'm going to start, because at the time I didn't have anything else. So then I decided, okay, how am I going to make this coil? Well, there's a couple different things I did. First of all, at the very base down here, there is a way to set the coil form onto something that's going to hold it. And I just happened to have a small piece of red oak. And I took a compass and I drew a circle that was the right inside diameter of the PVC. This is 2-inch PVC. I cut that out, used the Forstner bit and drilled the hole for the center. It slipped on perfectly. Then I took a couple of screws, one on each side, screws in here, and it holds it nice and tight. This isn't going to go anywhere. This stays really nice and snug. The aluminum goes up into maybe about this high. That's about it. And at the other end here, I was bound and determined I was going to use this hamstick over here. And I had a small adapter that would let me screw in a 3/8 24 thread. This bolts right here, and it's a solid piece so that I don't have it insulated or anything. I got a lock washer here, and I got another one on the base. This is an U-shaped bracket, and it screws in on 2 sides up here. And voila, there's the very top of my antenna. Now to connect the 2 together. Well, first of all, I had to figure out how long should this tube be. You have no idea how many drawings I had made by other people that talk about coils. They're all different sizes. They're all different diameters. Big caution, use only this size wire. Don't worry about that. It's just absolutely amazing. So I looked at these things and I said, well, let's start here at point A and we'll see where we go. What I did is I started figuring out rough inductances up here, and I said, well, they're using 12-inch tubes. I'm going to use a 12-inch tube. I'm not sure how many turns per inch, but I'm going to wind mine to 4 turns per inch because I know I can get a clip lead in between the 2 wires. So let's go with that. So I took my 20 gauge wire that I salvaged off a field coil, and let me talk to you a little bit about that wire first. You take the wire off, it's going to be kinked all over the place. I mean, it's been formed, it's been pulled, it may even have been varnished at one point. If you take a piece of it and you put it in a vise, you hold it tight, you take a small piece of dowel or a broom handle underneath and you hold it and you run this up and down a couple, 3 times, that wire is going to string out nice and straight. It just adds this, I'm talking soft drawn copper now. That is going to work just perfectly. And when you do that for this long piece of wire you're going to need, you're going to have a nice straight piece of wire. Just let it lay on the ground, because when you decide to wind your coil, you're going to wind it by hand, and that means you're going to start turning the coil by hand, and you're going to start winding the wire this way. And why? If you try to scramble wind it like that, you're going to have a mess, because the wire has got a twist in it. The way it was drawn and manufactured. So you need to make sure that you keep it straight. Well, I wasn't very smart first time I did this. And I wound it on this way, and I counted the number of turns as I went up. I got all finished, I tightened it down up here, and then I went back and I straightened this thing out by hand. And I said, jeepers, there's got to be a better way, but I'll work on that next time. Then in order to hold all of these in place, I used some PVC cement. For $2.79 you can buy a can of this stuff with a brush, built into it, and Home Depot, and I guarantee you're going to do about 5 or 6 of these coils with no problem at all. I've got 2 coats on here. Now, there's one other little thing to do with this particular coil, and that is, right here, these 2 little pieces of plastic. At some point, you're going to want to tap into this thing, because at different spots on the coil, here, for example, here, and here, that I marked these so I know where they are. Those are the 3 bands that I use on this one. I don't want to have to go out in the field and start counting 1, 2, 3. Oh, there's 4. That's for 20 meters. And here's 30 meters, and here's 40 meters. What I did is I took 2 pieces of plastic, about 1 inch shorter than the full length of the coil. Put some super glue on there, a couple little dabs here and there, laid them down, and now you've got this nice bump strip. So the wire gets wound up over the top right here, up over top and between. Now you can take your clip lead, which you will add with great importance, and you can now come down here and just clip it right on. Here you are. You got plenty of room to do this. This isn't going to go anywhere. If you don't like it up here, mount the clip lead down here and count the other way. I can invert this coil and it will work just as well. This is the way I built the first one. Now the second one is really built a little differently. And let me back up here. This thing back up.
Hit the arrow.
I'm hitting the arrow now.
Hit it. Hit escape. I don't get rid of that.
Now hit the arrow.
Now hit the arrow back.
Oh, there we are. Thank you. This coil is also hand wound, and instead of it being 4 turns per inch, this one is 7 turns per inch. And this time I was a little bit smarter. When I wound the coil, I decided I was going to make a little upside down U-shaped bracket this would sit in. A couple holes on each end of the bracket so it would sit in there, and I could nicely turn this. But at the same time I could hold the wire I was going to wind. And in order to continue to have equal spacing, I used some 3/16" nylon rope that I happen to have, and I stretched it next to it, and I just kept on turning it. And by golly, if it didn't stretch this thing out nice and neat. At the same time, I would go maybe about 10 or 15 turns, and inevitably the wire is starting to tangle on your feet, or on the chair, or on the dog, or something like that. So what I did is I took a piece of masking tape and wrap it real tight around there, and it would hold it right where I left it. Get things straightened out, you're set to go, just continue turning, and before you know it, you're all the way down the other end. This particular coil, the way it is, will tune all the way down to 2.4 megahertz. And this was purely experimental to see how far down I could get, and still hit 80 meters. Well, I overshot a little bit, which is okay. I'll learn better next time. Now, the other unique thing about this is a former A4S trap for 30 meters. And I say former. When you look inside of here, you're going to find this piece of aluminum is going to go down to about here. Then there's going to be a fiberglass insulator, and then there will be the rest, another part of the tube down here. On the insulator is probably, I would say some number 16 enamel wire that's closely wound. That's half the trap. The other half of the trap is a sleeve that goes over the top, provides the capacitance. You slide that up and down to move the frequency when you go to tune your vertical. I simply took all of that off. The trap was shot anyway because the outside element where it's swedged at the base, I was trying to taper it down so you could tighten it down with a hose clamp, had completely separated. Why, I don't know, but it did. I suspect some water got in there and it froze and expanded it uniformly and just popped it right out at the joint. But it didn't make any difference. This was only designed to hold the coil. I did the same thing. These happen to be maple, again, because I happen to have a scrap piece of maple. I cut one on this end, I cut a piece on this end. You can see where it's bolted together, and that's where the coil goes. The wire comes out, the wire goes down here, it comes out here, and then it's screwed into a solder lug right down here. And the same thing on the top, and that's also the same spot where I put the tap for the element. So you take a peek at that one.
Why is this one black, the other one's white?
Oh, I should tell you about that. Good point. This was black only because I decided I was going to clean it up a little bit. I had cleaned the PVC tube down as best I could. You know, there's 1,001 markings on those white tubes. Some are in red, some are in black, some come off, some don't, some smear, and that's the way it is. And it really looks gross. So what I did is I cleaned them off as best I could, put a strip of masking tape over where the tap section was going to go, and I sprayed the rest of it. I went over and I got some flat paint over at Home Depot, And I got about, 2-3 coats on there, and it worked just great. The only caution I have is just use plain, everyday, flat black, nothing with metal in it. You can read on the can, but believe me, $2.79 a can, it isn't even been sitting next to any metal. It's as cheap as you can get. But it looks a little bit better. Now, there's the difference between this coil and the last coil. This coil, the inductance is 57 microhenries. That's a lot of inductance. But you need that with the overall length of the antenna to get down in frequency to where you want to go. I could use at least half of that. I could get rid of if I just want to go to 40 meters. On the other antenna here, if I wanted to chop off from here all the way up to here, I could get rid of that with this particular spacing and the inductance that I'm using, and that would cover 40 meters. 40, 30, 20, and I'm on the air. The reason I don't go any more than those 3 bands is generally when you're in the field, those are the bands that are going to be propagating when you're going to be operating. I didn't bother messing around with 17 meters or 15 meters. That's very sporadic. And I'll tell you, a few years from now, it ain't going to make any difference. You're not going to hear much up there. So as a result, those are the 3 bands that I played around with. Okay. Hand winding is real easy. Don't worry if your coil isn't perfect. Believe me, it doesn't make one iota of difference. I've even wound, one of the first coils I made, I wound a square one. 4 pieces of dowling and a square block of wood on each end, and I wound it around there, and it worked just fine. Didn't look real pretty, but it worked great. Take your time. The coil is the fun part of the build. You're all finished, you're going to look at that, and you're going to say, wow. Grab whatever wire you can get. There is no right, there is no wrong. Just make sure it conducts. Cement the turns in place where they belong. Try to use brass or plated hardware. Rust is the enemy. And when you're outside, these things will rust up after a while if you're not careful. And again, be sure you use non-metallic paint. Well, it wouldn't be ham radio if we didn't have one formula that you could at least consider. If you want to play around and you want to look at the inductance and you want to start fiddling around with information about your coil, this is how you do it. This is a formula taken right out of the handbook. There is no magic to it whatsoever. And I've written a little coil inductance calculator you can download from my website. And I did that because I just wanted to play around. And I got sick and tired of putting numbers in and writing formulas each time and then dumping it out or saving it and forgetting which line was which. So I put together a little calculator. And anybody that's interested can get one, just download it. This is what it looks like. There's no magic. And this one happens to be set up for the second coil. 2 inches in diameter, there's 84 turns, and there's 12 inches of coil, and that yields you an inductance of 54.7 microhenries. There's 7 turns per inch. By the way, each turn all the way around once is 6.3 inches, so about 528 inches of wire, or about 44 feet. You can figure that out just like that. Let's say you've got this particular coil, or a coil, and you say, jeepers, I wonder what the inductance is that I need for 20 meters given the length that I've already established. Count the number of turns, put those in there, you know the length, which is right here, an inch, and you'll find out and calculate exactly what inductance you need. So if you're going to only operate 20 meters and you've got random lengths of wire or random lengths of tubing, that's how you figure it out. Bingo, you're right on frequency. Or leave yourself an extra couple of turns. Theory is great, but it doesn't always work in practice. So anyway, if you want one, that's where you can get one. Be sure when you put this thing up, you deploy the radials. I use about 25 feet of coax. I use RG8X. I've got several links that I splice together. And the reason is sometimes I get closer and sometimes I get a little bit further away depending upon where I'm stopped. The best way to tune this thing up, use an antenna analyzer. There certainly is one floating around here, which is a great thing to do. It's easy, plug it in, start playing around with the taps, find the one that comes closest to the operating frequency, make a note, and go to the next one. That's all there is to it. There is no magic. The alternative way, you can plug your transmitter in, look at SWR, move it, look at more SWR, and you can keep doing that until you find the spot where the SWR is the lowest, and you're going to come up to the same place that your antenna analyzer has come. Don't be bashful about changing these antenna elements. This is the element that sits on top of this. This is the whole antenna. Doesn't take much at all.
Which band is that hamstick for?
This one right here, this was a 20 meter at one time. Right now it's unique. The other antenna that I've got here is the base. Coil sits in here. This one sits on top of that, and this one plugs into the top of that. And again, the reason I made this a little bit longer is I was trying to make sure I got this thing to work right on 80 meters, and it does. If I were to take the top element off and just use this, I could change the taps on there. I would eliminate the 80 meters, and I would have an extra long coil that I would be using that much of the coil on. So this coil is going to be changed, by the way, because now that I've got one for 80 meters, so I don't operate on 80 meters at all, I will tell you that I will make this so that I've got a lot more turns to work with, and I can fine tune a little bit more in the upper frequencies.
That's one of the advantages of using a lot more turns, is you can fine tune frequency a little
Yeah.
bit.
The whole idea is you're supposed to have fun doing this. Don't turn this into a project. It doesn't have to be. It really does not have to be. Go out there and have a good time with it. Build it the way you want to, the way you're comfortable. You don't need a whole machine shop. You're going to see in one of these reference articles, there's a guy who's standing there holding this beautiful loading coil that he just created off his milling machine. I think you've all probably seen that on the cover of QST. And it's just a work of art. And I look at this, I marvel at this guy's workmanship, but you don't have to do that, believe me. A hand drill, I'm talking a hand power drill, and a screwdriver and a few screws, and you're in business, believe me. Don't forget the soldering iron though. You're going to end up with an antenna that really does work. You're going to find these things really play. When you think about this, and the overall length being about 13 feet, okay, what's a halfway 120?
16.
How much?
16.
There you go. You're only 3 feet short of a halfway 120. Okay, that little bit of coil down there is all you're going to need to get you up to where you need to be. Then you can use the rest of it to, electrically what you're doing is you're stretching that antenna a little bit longer. Hey, get this thing out in the field. Work in your backyard. Backyards are great. Nobody can see you back there. Sneak out behind the garage. If it blows up and it doesn't work, so what? You know, I mean, have a good time with it. They're really very simple. The whole thing is get out and have some fun with it. That's it. Questions?
With your emphasis on QRP, isn't coil Q and loss pretty important? And you kind of suggest that the wire doesn't matter, but
Well, I
maybe
say
the
the wire
secondary.
doesn't matter. I'm talking about, I wouldn't go out and use number 32, 33 wire.
sure.
No, this stuff happens to be 20 gauge, as a matter of fact, it's on the coils. I would say if you stayed 20, 22, 24 gauge, you're okay.
24.
Yeah, I wouldn't use anything smaller than that.
No, that's for sure. No, especially if you're going to 100 watts.
Well, even 100 watts, you'd be surprised how much that thing would handle. Yeah.
Okay.
You know, you don't have that big a mismatch. I'm able to get the SWR down pretty good. Keep in mind that if I was able to tap all the way around the coil and find exactly the right spot, I could really get that SWR right where I want it. I'm going with whole taps. And it's remarkable how close I can come. I think I'm down to like the lowest is 1.3 to 1 on 40 meters where I'm operating. That's next to nothing. Transmitter doesn't even know it's there. And my K1's got a built-in antenna to it, and I let it make up the difference. No, not the whole system doesn't even know it's there. Believe it or not, if you remember the name Walt Maxwell, who was my hero in terms of antenna design, and he's written a lot of articles over the years for QST. He designed for the first space shot the S-band antenna, and he built into it a 5 to 1 SWR. And he did so because that was the best way to couple the output of the transmitter to the antenna at that particular frequency, and he went into this big long dissertation, which I frankly don't understand. But he designed it with 5 to 1 SWR, and obviously it worked. I'm not a real proponent of worrying about SWR to a degree. I mean, obviously you're going to get one spot where the coax is nice and warm, nothing else works, and you're going to say, gosh, I don't understand why. But frankly, as long as you keep the SWR below 2 to 1, you're okay. No any problems. Good question. Anything else?
How about chokes keep RF from coming back towards the room?
I've never used one, to be honest with you. I've never even considered doing that. I've never had a problem with it. It certainly would be something to try. I certainly would encourage that. My suggestion would be if you've got that much RF coming back, then you've got a design issue, or you've got the wrong tap, or your coil is just simply running out of inductance to provide proper loading for the overall length of the elements. That would be my suggestion. Again, all of these antennas, if you were to try to duplicate, let's say the first one, the easiest one to duplicate, and you were to put them side by side, I guarantee you your readings would be a little bit different than this one. It's bound to happen. That's just the way it is in practice. Yeah. Yes, sir.
What was the length of the radios?
16 feet. Yes. In fact, the wire that I use for the radials is some old rotor cable. I just happen to have a piece in my wire junk box that I've been lugging around from house to house to house. And I always thought someday I was going to find a good use for it, and this time I did. I just snipped off a 16-foot piece and separated 3 wires, and, well, actually 6 now, and there we are. Those are the radios.
Is it usable with, say, a single radio? Does that improve over trying to drive it? I'm thinking of a situation I've got where I have a vertical mobile mounted right next to my air conditioner, but not a ground radial on it right at this point. I just put it up so.
If you put some ground radials in, believe me, you will notice a significant difference.
Run those all along the house base.
Yeah. Leave it where it is and just try to bury some radials, obviously, if you want to keep it nice and,
I'm in a townhome, so I can't dig up the yard.
Yeah. Or just simply lay the radials on top of the ground, get it really nice and low, and let the grass do its thing. Inside of a few weeks, they'll disappear. Obviously, the more you put down, the better it's going to be. What you're trying to do is you're trying to overcome the ground losses. And the wire does a really good job of that. Now, where I am in Fridley, I've got 6 to 8 inches of really great topsoil, and everything else under that is all sand and gravel. So the only conductivity I've got is whatever happens to be in that top 6 inches. And I'll tell you, there isn't a whole lot there. So that's why the wire, the long wires for my radials, for my other base vertical, are in there. And it took a little bit of time to do it, but it's easy to do. And certainly it certainly plays, I'll tell you that. It makes a huge difference at times. Anything else? Thanks a lot.
If you decide to